All right, so today is 30, 60, 90 triangles. This is the other special right triangle. So previously we did 45, 45, 90, which was an isosceles right triangle. Now we're going to do 30, 60, 90. And what happens in a 30, 60, 90 triangle is that the hypotenuse is twice as long as the short leg. The hypotenuse is twice as long as the short leg. And the long leg is the square root of 3 times bigger than the short leg. So again, let's talk about the short leg, long leg hypotenuse. Well, we know that the hypotenuse is always the side that is across from the 90-degree angle. Next, short leg, long leg. Remember what we know about angles and sides. So since this is a 30-degree angle, across from the 30-degree angle is going to be referred to as the short leg. And I abbreviate that with SL for short leg. Across from the 60-degree angle, so since 60 is bigger than 30, then that's going to make this side of the triangle larger. And so this is referred to as the long leg, or abbreviated LL. So none of the pieces here are the same size like they were in the 45, 45, 90. So basically what happens is you always have the 30-degree angle, then the 60-degree angle, and then the 90-degree angle. So if you start with the short leg and just say, all right, the short leg is always going to be X. And I think about that, I always say maybe it's like home base. It's where you begin. And it's like the smallest angle, so that's where everything started. All right, next, the long leg is the short leg, but it's longer than the short leg. How much longer? It's the square root of 3 times as big as the short leg. So again, you have to still wrap your mind around that the square root of 3 is a number. So, you know, the long leg is getting longer. That's actually like 1.7. So it's that much longer, but we're just keeping everything pretty. So remember, that radical is not meant to scare you and like make you think you don't know what you're doing. It's just there to keep the number pretty. So it is that many times larger than the short leg. Now the hypotenuse is always twice as big as the short leg. So this is one way you can do these problems, is that you can create your table like this and you can work from here. And I'm going to show you a couple of different ways and then you can pick the one that suits you best. All right, so here we go. Example number 1. And again, this is a shortcut to Pythagorean theorem. If you can use Pythagorean theorem, it's a shortcut. And it's also a shortcut to using trig. So you always, always, always have the option of using trig. I cannot emphasize that enough. You just have to know that when you use trig, your answers are going to be approximate. And I'll show you what I mean by that on this number 1. So let's just try number 1. So the side that is opposite the 30-degree angle is going to be the short leg, right? Well, it is always X, home base. So we're going to take that pattern from the star chart. So this is also on the star chart, and this is the pattern I'm referring to. When I say pattern, I mean the X's, like that's X, this side is 2X, and this side is X times the square root of 3. So that's the pattern. So we're going to take that pattern, and we're going to apply it to our problem. And sometimes I like to do this in a different color so that you can override any other variables, because you don't want to get your pattern confused with the variables that are already in the problem. So this side is X. The hypotenuse is always 2X. And the long leg is always X times the square root of 3. All right, so again, just like we did 45, 45, 90, wherever they gave you information, so they told you that this side was 2 units. You circle what they gave you, then you make an equation out of that. So right now, X is equal to 2. So wherever in the pattern there's a 2, an X, you're going to replace it with a 2. So here, Y up here is just 2 times the square root of 3, and x is 2 times 2, which is 4. So let me show you how this looks. The short leg is 2, the long leg is 2 square roots of 3, and the hypotenuse is 4. So you can see the pattern here. This is x times the square root of 3, and this is 2x. So again, this is all I need to see. If you can give me these answers without doing any of this over here, hey, it's your lucky day. I am totally okay with that. All right, number 2. And I'm going to show you kind of the other way you can also work this problem. You can make the chart like I mentioned before. So you're going to make a 30, 60, 90 table. And you know that the x is 30, across from the 60-degree angle is x times the square root of 3, and across from the 90-degree angle is 2x. Then you're going to plug in the information you know. Well, here is the short leg, so it is x. Across from the hypotenuse is 6, so that's what they gave you. And then across from the 60-degree angle is your y, that's the long leg. So basically, you're going to start in the chart with what they gave you. And again, it's very similar to what we did on the first one. So here, what they gave you is that the hypotenuse is 6. So again, you're making an equation out of that. You're thinking, what did they multiply 2 by to get 6? Well, if you divide by 2, then their x in this situation is 3. So now you go in your table. Wherever you see an x, you put a 3. So that means the short leg is 3, and the long leg is 3 square roots of 3. So here are all the lengths of the sides of the triangle. Alrighty, number 3. So we have here, this is always x. This is x square roots of 3 and 2x. Circle what they gave you. You're going to make an equation out of that. Well, x squared root of 3 right now is equal to the square root of 3. Well, guys, you should be able to see this. If you divide by the square root of 3, then x is just equal to 1. So over here, your short leg is equal to 1, and your hypotenuse is equal to 2. So there are the other lengths of the legs and the hypotenuse. All right, number 4, I'll do the chart. So I'll kind of go back and forth so you can pick which one you like to do. So here we go. This is x squared to 3, and 2x. Now remember again, this information is on the star chart, so you don't have to worry about memorizing it. You can always look at the star chart to find the pattern. All right, so what did they give you here? I see a 10. It's across from the 90, so they gave us the hypotenuse again. So I'm going to box, circle, what they gave me. So 2x is equal to 10, which means x must be 5. So wherever in my table I see an x, I'm going to put a 5. So the short leg is 5, and the long leg is 5 square root of 3. Now I mentioned you can do trig, but when you do trig, your answers are not going to be in exact form. They're going to be in approximate form. So you can do trig. You can use this angle, and you can do opposite. And then you can do, I don't want to find that side. I want to find this side. So we're going to do adjacent and hypotenuse. So A and H would be cosine. So cosine of the angle is equal to the adjacent over the hypotenuse. Solve. So x is equal to 10 times the cosine of 30. So if I put that in, I'm going to go 10 times cosine of 30. I get that x is equal to 8 point. So that answer is 8.66. Now, on the exams and tests, your answers are more than likely going to be in exact form. Remember, exact form is radical form. So for the long leg here, all right, the answers on your test are going to look like this. If you're doing trig, your answer is going to look like this. You have to know that those are the same thing. How do you know they're the same thing? Well, if you had answer choices here of A, B, C, and D, and A said 4 square roots of 3, and this said 3 square roots of 3, 5 square roots of 3, 6 square roots of 3. So if those are your answer choices, but you did trig and you came out with this, your job is to find the approximate value of all of those. So you type that in your calculator, 4 times the square root of 3. Well, that's 6.9. Right? So that one doesn't work. And you just keep going through until you find the same approximate value that you came out with. All right? That's how, if you're doing trig, you have to be able to convert the exact answers into approximate answers so that you can like pick the right one and double check your answer. Okay. We need to do number 5. Here we go. So across from the 30 degrees is always x. Across from the 90 is 2x, and across from the 60 is x square roots of 3. So here we go. They gave us this, so that means x is 7. So basically here, my short leg is 7. My long leg then will be 7 times the square root of 3, and my hypotenuse is double the short leg, and you're done. Good job. So again, do Pythagorean theorem. Remember, to do Pythagorean theorem, you need 2 out of the 3, though. And again, when you do that, your answers are going to be in approximate value. So just the same thing, you're going to have to convert your answer. All right, number 6. Here we go. We have across from the 30 degrees, short leg, hypotenuse. This is long leg. The piece they gave you, you're going to circle. So right now, x square root of 3 is equal to 6 square roots of 3. You've got to be able to say, well, what is x? Well, you can pretty clearly see what's in place of the x. But if we solve there, we see that x is 6. So right here, our short leg is equal to 6. The hypotenuse then is double of that. And the long leg is what they gave us, is 6 square roots of 3. Now, what is the perimeter of number 6? Remember, perimeter is when you add up all the sides all the way around. So we have short leg, hypotenuse, long leg. So when you are combining like terms or simplifying these radicals, you only combine what is alike. So what is alike in this case are the whole numbers, because 6 square roots of 3 is not a whole number. Remember, that's why they're writing it like that, is because they want to keep it all nice and pretty. So 6 square roots of 3. So you're only combining those. That's 18. You can't combine this with anything else. So that is your answer. Again, you can do this. You can add it all up in the calculator, but your answer on the test is going to look like this. So you have to check, what's the approximate value? 18 plus 6 square roots of 3 gives you 28.4. Well, you can also put all of this in the calculator, and it makes sure it has the same approximate value. If I did 6 plus 12 plus 6 square roots of 3, I get the same exact approximate value. So always be checking your approximate values when you're working with radicals. Okay, number 7. Across from the 30 degrees short leg is x. The hypotenuse is 2x. Across from the 60-degree angle is the long leg, which is x square roots of 3. I'm going to circle what they gave me, and I'm going to make an equation out of that. So 2x is equal to 10 square roots of 3. So if you notice, this one looks a little different. Not all of them are going to be nice, neat, and pretty like 1 through 6. We're just easy. We were banging them out. Sometimes you're going to have to do a little bit more solving, like in this case. So we got to get x by itself. So we're going to divide by 2, divide by 2. Those 2's are going to cancel. We're just going to simplify again. When you're messing with radicals, you simplify what's alike. You leave the radical alone. So 10 divided by 2 is 5. So this becomes 5 square roots of 3. So your x right now is 5 square roots of 3. So wherever there's an x in your pattern, you're going to put 5 square roots of 3. So let's look at that in the chart. All right, so they gave us that this is x, x square roots of 3 2x. We got that the hypotenuse is 10 square root to 3. Well, now we determined that x is equal right there to 5 square root to 3. So wherever in this pattern I see an x, I'm going to put 5 square root to 3. So the short leg is 5 square root to 3. Now what happens here is that you have 5 square roots of 3 is replacing the x, and that is multiplying by another square root of 3. If you need the calculator, go ahead and use it. Again, this is meant to be a shortcut and meant for you not to have to use the calculator, because you can do this, guys. I know you can. This is square root of 3 times square root of 3, which is the square root of 9. Well, what is the square root of 9? It is 3. So this is 5 times 3, which is 15. So this long leg here is 15. So those are the side lengths for that triangle. Again, a little bit more solving. You can do this in your calculator. Parentheses, 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 always around a term. Okay, number 8. Across from the 30-degree angle is x. Across from the hypotenuse, that should be a 90-degree angle there. Sorry about that, is 2x. And the long leg is x squared to 3. Circle what they gave you. So that means x is 7 squared to 3. So wherever in your pattern you see an x, you're going to plug in the square root of 3. So the hypotenuse is 2x, which means that is 2 times 7 squared to 3. You just multiply what is alike, which gives you 14 squared to 3 for your hypotenuse. The long leg is x times the square root of 3. So you have 7 square root of 3 times the square root of 3. So remember, we just did that over here, which is 7 square root of 9. The square root of 9 is 3. So we actually get 21. So we have, here's the short leg. We have the long leg is 21. The hypotenuse is 14 square root of 3. All right, so number 9. Here we go. We have x, 2x, x squared to 3. So circle what they gave you. So right now, x squared to 3 is equal to 2. Well, unfortunately, we need x by itself. So we're going to divide by the square root of 3, divide by the square root of 3. It's not going to look so pretty, but remember, we're not afraid of radicals. We're going to say, okay, it's okay. I have a calculator. This is what x is. X is 2 divided by the square root of 3. Which means your short leg over here is just that. Your short leg is x, which is 2 divided by the square root of 3. We're just going to leave it. It's okay. The hypotenuse is 2x. So basically, we have 2 times 2 divided by the square root of 3. So remember, we're multiplying. You can put that in your calculator, ladies and gentlemen. This gives you just multiply across, so we're going to get 4 over the square root of 3. So that's the hypotenuse. This is the short leg, and your long leg is 2. All right, now equilateral triangles. This is where all sides are congruent in an equilateral triangle. Therefore, we have learned if all sides are congruent, then all the angles are also congruent. Now, what else we have to remember is that the special segment, remember the median, altitude, all of those things you love from any vertex in an equilateral triangle, so any of these that come down from any vertex, so it can be from there, it can be from that direction or that direction. Whatever vertex it extends from, that special segment is actually all of them, so it is the median. All right, we do that. Segment is the median. That segment is also the same exact segment as the altitude, and it's also the perpendicular bisector. So I'm telling you this because, so we have an equilateral triangle. So if it's equilateral, it's also equiangular. So 60, 60, 60. We have a special segment that drops down. Oh, bam, that's the median. That's also the altitude and the perpendicular bisector. So it's cutting this side in half. So my point of this is an equilateral triangle splits into your special right, a 30, 60, 90. Because if you split that angle in half, that's going to give you 30 degrees up here here's your 90, and here's your 60. So you need to know that inside every equilateral triangle are two 30, 60, 90 triangles. Now we're going to use that idea. So the frame of the clock is shown is an equilateral triangle, okay? So I'm going to go ahead and just redraw this and say, okay, equilateral triangle. The length of one side of the frame is 20 centimeters. Will the clock fit on a shelf that is 18 centimeters below the shelf above it? So what is that asking? It's saying, all right, we have a shelf here, and it wants to know if this clock will fit on the shelf. Well, all we know is that this diagonal piece is 20, and this in here is the distance between the shelves is only 18, and it wants to know if it fits. So basically what we have to find is this height of that clock. Well, we can find the height because now we have a special right triangle. So if I were to redraw just my special right, that's 90. This corner is 60, because remember, the corners are 60, and you're going to split that one up top to be 30. If all the sides are 20, and you take out just this piece, that makes the hypotenuse 20. The short leg is 10. Now looky here. This is the long leg. Well, the long leg pattern is that this is x times the square root of 3. Well, here is your x. So this height, or long leg, is 10 square roots of 3. Again, that's exact. You need to check the approximate value to see if this can still fit in between 18 centimeter shelves. So if you do 10 times the square root of 3, that is your approximate value of 17.3. So that's the height of this clock. So yes, it will fit. Barely, but it fits. All right, next, this tabletop is an isosceles right triangle. Oh, there we go. Remember, isosceles right triangles. If the legs are congruent, that means the angles are congruent. Well, if those angles are congruent, then they have to be 45 degrees. So every isosceles right is our special 45, 45, 90. The length of the front edge of the table is 48 inches. All right. What is the length, W, of each of its side edges? So it wants to know what are these lengths here. They tell us that this is 48. Here, remember the old pattern, or it's on your star chart for the 45, 45, 90, is x, x, x square root of 2. So you apply that pattern to your picture. X squared to 2, x, x. Circle what they gave you. So x squared to 2 is equal to 48. We've got to solve for x. So x is equal to 48 over the square root of 2. Well, that just happens to be right there what the length of your legs are. This says round to the nearest tenth of an inch. So basically, we have to take our exact and turn it into approximate. So you do 48 divide by the square root of 2, and that gives me 33, and I'm going to round to the tenth, which is 1 decimal. So this is approximately 33.9 inches is one length of the table.